everyone, welcome back to another video. So today we're going to be going over this problem which states a frictionless pulley which can be modeled as a 0.8 kilogram solid cylinder with a 0.3 meter radius has a rope going over it as shown in the figure below. The tension of the rope is 10 newtons on one side and 12 newtons on the other, and they want us to find the angular acceleration of the pulley. Alright, so here's how we're going to approach it. So basically we have two torque equations, right? So let's write those two torque equations out. So we have sum of the torque is equivalent to the distance from the pivot point times the force perpendicular. And then the other torque equation is sum of the torque. I should write the t's like the same. Sum of the torque is equivalent to the moment of inertia times angular acceleration. And so what you're going to find here is, hey, look, the angular acceleration is in one of the torque equations, which is what we want to find. So if we want to find this value, we're going to need to know the moment of inertia and the net torque. So the moment of inertia, it should be provided to you based on the solid cylinder according to AP Physics 1 guidelines. So the moment of inertia equation for a solid cylinder is 1/2 times mass times radius squared. And you'll see in the problem that they give us the mass, 0.8, and they give us the radius. And so we're able to calculate that. But now we need to know the net torque, right? Because if we know the net torque, then we can just isolate and solve for the angular acceleration. So in our case, the net torque can just be calculated using this equation. And so this equation above is something we can utilize to find the net torque, right? So let's just set it up using our numbers and see what we get. So our net torque is equivalent to, let's see what's acting in the positive direction. So the positive direction in torque is characterized as the counterclockwise direction. So the rope that's going towards the counterclockwise direction is the 12 newtons. And so that is our positive force. So the distance from the pivot point would just be the radius. So 0.3, multiply that by 12 newtons, and there we have our first part of our torque. So this would be torque counterclockwise, otherwise known as positive. But now we have that negative end, right? Because the 10 newtons is going the other way. So now we have to subtract 0.3, that's the R, times 10 newtons. And so this side is the torque that's acting clockwise, otherwise known as negative. And that gives us net torque equals about 0.6 Newton meters. So now, like I said before, now that we know the net torque, we can just plug it in with our other values. So using this equation, we can just say 0.6 Newton meters is equivalent to 1/2 times the mass, which is 0.8 kilograms, times the radius squared, and they give us the radius 0.3 meters squared, and that is multiplied by the angular acceleration. So now we can just divide both sides by whatever the moment of inertia is to get the angular acceleration. So 0.6 over 1/2 times 0.8 times 0.3 squared, and that will give us a value of 16.667 radians per second squared, or around 17 radians per second squared as our final answer and as the angular acceleration. All right, so I hope you guys learned something. If you have a question, just drop it down in the comments below, and thank you for watching.